I'm going to find the slope m of the line passing through the points 1, 2, and 4, 6. I'll start this problem with a drawing of the points in a coordinate system. To draw a coordinate system, you need a horizontal axis and a vertical axis. The horizontal is called the x in math. And we need a 0 for our horizontal axis. Now the x values in question are going to be the numbers on the left in the pairs. So this one here, the number 1, is going to be what I'll call x1. And the number 4 can be what I'll call x2. So we have two x's in question. So I want my number line then to at least show those numbers, 1 through 4. Okay, so we're going to be starting here at the number 1 and then ending here at the number 4. So this could be my x1 and this is my x2. I'll make the x2 a different color. So just using the horizontal information alone, I don't know the elevation of the points in question until I look at the second coordinate, and we'll give those the names y1 and y2. Here I'm talking about the blue and the purple. But I do know that my points are going to be located somewhere above or below the number 1 and also above or below the number 4. Alright, so now I'll focus on the vertical axis. The vertical axis goes right through the 0 of the x-axis, and we just have to give it some numbers. The 0 of it is going to start here. Then we'll go to 1 and 2 and 3 and so on. The vertical axis is going to be the y in math. And this is going to give us the elevations of our points. So if you look at the blue here, it's got an elevation of 2. So I want to start from the x-axis and then go up 2 units to plot my first point. So this guy has to go as high as the number 2 is on the y-axis. And so this is the point 1, 2. We go over 1, up 2. Alright, now for my final point, we're going to start here at the 4 of the x-axis, and we have to go up to an elevation of 6 units. And that's going to be our final point, 4, 6. Now we plotted both the points in a two-dimensional coordinate system. My next task is going to be to connect, and we're just going to draw a little right triangle. The right triangle that we want to draw has its base touching the first point, and it's got to be a horizontal base there. Then we want to connect it to the second point with a vertical segment, and so the vertical there is going to be referred to as the rise of the triangle. The horizontal is referred to as the run. My goal now is to calculate a number for the rise. You find the rise by subtracting your y2 minus y1 in order to get the difference between them, our y2 was 6 and our y1 was 2. So we're going to find what's called delta y by subtracting y2 minus y1. That's 6 minus 2. And so it's 4. The rise is 4. Now we'll calculate the run. To get the run, we want to get a subtraction of x2 minus x1. So my x2 is the green, and my x1 is the yellow. So we want to subtract 4 minus 1. And I get 3. So my run is 3. The slope of a line has a formula. It is a rate or fraction of rise divided by run. Symbolically, it looks like this. M equals delta y over delta x. If you're trying to estimate the slope of a curve such as that, you would want the bar over the head of the slope to indicate that it's an average slope. And the formula says we should do y2 minus y1 over x2 minus x1. So we can plug it all into the formula at one time if we want. Where the y2 goes here, y1 goes there, and in the denominator we have x2 and x1. At this point, it's all about plugging the right things into the right place. So for y2, we have 6. For y1, we have 2. Our x2 is going to be 4, and our x1 is 1. After we simplify the top and bottom here, we're going to get 4 over 3 as the slope. Now, in addition to showing how to do this by hand, I'm also going to show how to do it using technology. Let's try the app Desmos.com. Now, if we want to just see the points on the two-dimensional plane, we can actually just type them in exactly like they appear. Put 1 point in each row here. And these are the 2 points in question that I had plotted. And as you can see, it looks quite like my picture. If we want to calculate the slope between them, though, we have to take a couple additional steps. First, I would hit plus and add a table. And now I just want to put my 2 coordinates into the table. So the x1 goes with the y1. That's the 1 and the 2 in the first row. And then the x2 and the y2, they go together in their own row as well. At this point, you would want to use a thing called regression to get the slope. So the command for linear regression in Desmos is going to be similar to y equals mx plus b. This is the slope-intercept form of a line, but we have to modify it just a little bit in the program to get it to do what we need. For one thing, we have to use 1s on our x's and y's because our table has 1s in it. And also, in order to do regression, you can't use the equal sign. You have to use a tilde in Desmos instead. Okay, so the program is going to draw a line between the points in question, and it's also going to calculate that slope. Now, one drawback of using the program here is it's not giving you an exact value of the slope, but it's given you a numerical approximation of it. So see 4/3, if you divide it on calculator, comes out to 1.3 repeating. Or you could use a TI calculator to get an answer. Let me show the TI method. Okay, this is a TI 84 Plus CE calculator. So in order to get the slope with regression on calculator, what I would do is first hit the Stat button and hit Enter to edit the lists. At this point, you want to make a table. Yeah, so we'll put the X1 together with Y1 in a row, and then put X2 with your Y2 in the next row. Now you'll hit Stat again, go over to Calc, select Linear Regression, and you don't have to change anything here. Hit Calculate, and the program will give you the slope. In this calculator, A stands for the slope of the line.